Hi friends, today we are going to discuss about the dimensionality reduction principal component analysis part 1. So the whole concept of the PCA I was divided into two parts. So first one I'm going to explain this in this lecture. So those topics are the what is dimensionality reduction, why dimensionality reduction, so curse of dimensionality, PCA, applications and limitations of PCA. So those topics I will cover in this lecture. So rest of the topics I will cover in the next lecture. So those topics are the mathematics behind the PCA and the PCA in Python. So let's discuss about this lecture topics. So what is mean by dimensionality reduction? So dimensionality reduction is a technique to reduce the dimension of the feature space. So dimensions is nothing but the features. So dataset contain the number of the features. So those features we have to be more number of features. Those features we have to reduce. So dimensional reduction is a method of converting the high dimensional variables into lower dimensional variables without changing the information of the variables. So without changing the information of the variable, we supposed to converting the high dimensional space into the lower dimensional space. So example that, for example, our dataset contain 100 features or 100 columns, which means this is our data. So this is the feature 1, feature 2 up to feature 100. So out of the this is the total dataset contain 100 features. So and we want only 15 features. So we want to use the 15 features by using the dimensional reduction technique. So which means that we can transform the high dimension means 100 features into the lower dimension like 15 features without changing the information. So which means that for example n is equal to 100 number of columns and n1 is equal to 15 columns. So we have to we have to convert the 100 features information into the 15 features information. So there is nothing but the dimensionality reduction. So why dimensionality reduction? So dimensionality reduction is an important in the machine learning for the huge dimensional dataset. So the most important reason for the dimensional reduction is the curse of dimensionality. So what is mean by curse of dimensionality? So the curse of dimensionality happen when increasing the number of the features, the accuracy of the model is decreased. Means while going to increase the number of the features, so the performance of the model may decrease, which means the accuracy of the model may decrease. So what is mean by dimension? So dimension is nothing but, for example, the dataset contain the this is the x1, x2, x3 and y, which means this is the 3 plus 1, which means the number of the independent variables are 3 and 1 target variable. So total 4. So the dimension is 4 number of the columns. So dimension nothing but the features are the columns. So these features may be independent or dependent. So we used to call these features as the attributes. So let's understand the curse of dimensionality with the help of the examples. For example, our dataset contains the 500 features. So from these 500 features, we are going to build the different machine learning models. For example, we are going to build the 5 models. Model 1, 2, 3, 4, 5. So what is the difference between among these models? Which means that the difference is here number of the features. Each model has the different number of the features. For example, if you see here, so my data set contain totally 500 features. So out of 500 features, for example, I may choose the 4 features. By using these 4 features, I have to train my model 1. So I got the accuracy 75%. So next time what I did, I add the 2 more features, which means 4 features plus I add the 2 more features. that is 6 features. So by using the 6 feature I have to train the model, another model, and I got the 85% of accuracy, which means if you increase the number of features, the accuracy is increasing. So now I have to add two more features from to 6 to 2, now it is 8 features. So my accuracy got to be increased from 90%, from 85 to 90. For example, I have to take the 50 features. So my accuracy may be 70%, which means it may reduce it from 90 to 70. If I take the 500 features of the dataset, my accuracy too worst compared to the rest of the accuracies. So why it was happened? Let's see. So suppose I'm taking one kind of a problem statement that is nothing but the insurance premium amount. So this is the dataset. For example, this dataset contains the 500 features. So feature x1, x2 up to x500, x500. So this is the insurance premium prediction dataset. So for example, out of 500 features, I have taken the first 4 features. I am taking the 4 features, only 4 features randomly I have taken. So I train the model on these 4 features. Out of the 500 features, I got the 75 accuracy. So then next time I choose the another model and same data set with 6 features. So I got the accuracy 85, which means accuracy was increased from 75 to 85. So why model 2 was increased from 75 to 80, which means that so model 2 has the more information compared to the model 1. So which means that model 1 was trained with the 4 features, got the 75% accuracy, and model 2 has been trained with the 6 features, got the 85% accuracy, which means the more information is required to improve the accuracy. Similarly, I taken the another model, model 3, and the 8 features, I got the 90% accuracy. So which means compared to the accuracy 1 and accuracy 2, accuracy 3 was improved, better. So as we increasing the number of features, what you observed here, so as we increasing the number of features from 4 to 6, 6 to 8, so the model accuracy was increased from 75 to 85, 85 to 90. So while increasing the number of features, so accuracy may also be increasing. But so we are going to increasing the number of features. But increasing the number of features, there is a kind of threshold value. So after certain threshold value, the model accuracy will not be increasing. For example, 4 features 75% accuracy, 6 features 85% accuracy, 8 features 90% accuracy. Suppose while increasing the number of features, accuracy may be increasing. But so while increasing the number of features at certain point of time, at certain point, certain value, after, for example, certain value will be 10. So up to 10, while increasing the number of features, it may increase. So after this threshold value 10, even suppose I'm taking the 15 features, my accuracy may be decreasing. So that is nothing but the threshold value. So here I'm taking threshold value 10, means the number of features 10. If more than number of features 10, so accuracy may be decreasing. So after reaching of the threshold value 10, means model 4, we have to train the model 4 with the 50 features. So we got the accuracy 70. So this accuracy is less than the 8 this accuracy, means 8 features we have to train the 8 features, we got the 90% accuracy. So 50 features we have to train with the model number 4, we got the 70% accuracy, which means that so while increasing the number of features after at threshold value 10, so the performance will be decreasing. Similarly, I am taking the 500 features of the data. So 500 features of the data, I have to train the model number 5. So my accuracy getting very worst, 60%. So 65%. So 500 features I have to train, I got a 65%, which means that so while increasing the number of features at one level, the accuracy may be increasing. So after that one threshold, for example, threshold is any value. So I am taking the threshold is 10. So after threshold value, it is crossing the number of features, the performance will be decreasing. So this is the concept of the curse of the dimensionality. So why accuracy is decreasing? Why accuracy is decreasing even after increasing the number of features? Generally, if features are increasing, so accuracy is also be increasing. But here, my accuracy is decreasing even after increasing the number of features. Why? So it means that so before some threshold value, so model is learning from the information very well, but when we increase the number of features, the model get confused. So when we increase the number of features means after threshold value, threshold number of features is 10. So after 10 features, if you are supposed to train the model, so model get confused. So because of we are feeding the model with a lot of information, so the model is not able to train well. If you take the more number of features, than the threshold value, so at the time your model not able to train well and with the correct information. That's why accuracy is decreasing. So after certain threshold value, when accuracy is decreasing by increasing the number of features, so at threshold value, so from 4 to 6, 6 to 8 features are increasing, accuracy also be increasing. But at a threshold value 10 features, after 10 features even features are increasing, our accuracy will be decreasing. So this is the concept of the curse of dimensionality. So how to overcome this curse of dimensionality? There are the two possible ways we can solve the curse of dimensionality. The first one is the feature selection techniques, and second one is the dimensionality reduction technique, that is nothing but PCA, which means with the help of the feature selection techniques we have to overcome the curse of dimensionality. Second one is the PCA, principal component analysis. So the feature selection technique select the subset of the features, not all relevant features, and pass these features for model training. So the model generated by the subset of the features is more accurate than a model with the all features. For example, I have the 50 features. After features, I have to apply the feature selection techniques. So feature selection techniques, what it will happen, it will select the best independent parameters, best independent variables, means a subset of this all features. Those features have to train the model and you get the better accuracy. So for feature selection, there the different techniques are there. Those are the filter methods, wrapper methods, and embedded methods. So in upcoming videos I will make the one video on about the feature selection techniques, don't worry. And one more technique is the principal component analysis. So it is also overcome the problem of curse of dimensionality. So curse of dimensionality problem can be solved with the help of the two techniques. First one is the feature selection techniques, second one is the dimensionality reduction technique, that is nothing but the PCA. So what is mean by PCA? It is a unsupervised dimensionality reduction technique that enables us to identify the correlations and patterns in a dataset so that it can transform into a new data set of significantly lower dimensionality without loss of any important information. So without loss of any information, we have to change the 50 features of the data can convert it into the 10 features of the data. So PCA can help to identify the correlations between the data points. So PCA does not create any subset of the useful features in our data, which means PCA does not select any best features. So feature selection is actually feature selection techniques and PCA both are used for the dimensionality reduction techniques, but thing is that feature selection technique can select the best features out of all features, which means feature selection techniques working based on the subset of the features, but PCA, principal component analysis, not like feature selection techniques. So PCA will help to reduce the data without losing the information. That is nothing but the PCA, which means PCA does not create any subset of useful information like feature selection technique. So speeding up the machine learning training via feature reduction. Yeah. So if it is 50 features, if you train your model, it will take, for example, uh, 30 minutes time. If you take the uh, 10 features, it will take the 10 minutes, which means that so machine model has been speed up with the help of the reduction technique by using the PCA. So applications of PCA. So dimensionality reduction. PCA is mostly used as a tool in the EDA, means exploratory data analysis, for making the predictive models. So visualization of high dimensionality data. If we have the high dimensional data, it can be hard to plot the effectively. If high dimensional data, it is very difficult to plot. So find the essential features, means feature selection within the high dimensionality data, and PCA is used for finding the patterns in the data. So these are the applications of the PCA and limitations of the PCA. So what is mean by limitations? So PCA works well, but there is some kind of significant drawbacks. So what are the drawbacks? First one is the independent variables becomes the less interpretable, and the data standardization must before the PCA, information loss, and not for good visualization. If you see, independent variables becomes the less interpretable, which means that so after implementing the PCA on this data set, so our original features will be turned into the principal components. So original data will be converted into the principal components. These principal components are the linear combination of their original features. So these principal components we are not able to readable. So those data we can't able to understand. So data standardization is a must before PCA. So we must apply the standardization technique, which is a scalar technique, before implementing the PCA. So before implementing the PCA, first we are supposed to apply the standardization. We have to bring the data into same range. So otherwise PCA will not able to find the optimal principal components. So this is one of the limitation. And information loss. So principal components try to cover the maximum variance among the features in the data. So if you don't select the number of principal components, so actually if it is 500 of features in the data, you can convert into the lower dimension. So here we have to select the number of principal components, for example 10, 5, 20, like that. Suppose 500 features, if I have to select the PCA is equal to 10, which means 500 features of information when be converted into the 10 principal components information, which means what are the information covered by the 500 features, the same information most probably covered by these 10 features, which means the dimensionality may be reduction. So which means that so information loss. So even principal components are try to overcome this variance among the features in the data. If we don't select this number of principal components, for example this principal components we are not able to selecting, so it may lose some information of the original data. So not for the visualization. So PCA works well only for the dimensionality reduction. So however it will not perform as expected when it comes to data visualization. So these are the limitations of this principal component analysis. So this is the concept for this lecture. So this is the reference I am using for making this PPT. So in next lecture I am going to explain the mathematics part and this programming part. I hope you understand this lecture. Thank you.